Imagine the ground beneath your feet suddenly beginning to shake. Buildings sway, objects fall, and a deep rumbling fills the air. This powerful, sometimes terrifying event is an earthquake. Earthquakes are one of nature's most dramatic displays of power. They can happen anywhere, at any time, and understanding why they occur is a key part of understanding our dynamic planet. Simply put, an earthquake is the shaking of the surface of the Earth. This shaking is caused by a sudden release of energy in the Earth's crust. This energy creates seismic waves that travel through the Earth. When these waves reach the surface, they cause the ground to tremble and shake. To understand earthquakes, we need to look at the structure of our planet. The Earth isn't a solid, unmoving ball. It's made up of several layers. The outermost layer is the crust, which is relatively thin and brittle. Beneath the crust is the mantle, a much thicker layer of hot, dense rock. The Earth's crust and the uppermost part of the mantle are broken into enormous pieces called tectonic plates. Think of them like giant puzzle pieces covering the Earth's surface. These plates aren't fixed in place. They float on the semi-fluid rock of the lower mantle and are constantly, though very slowly, moving. Earthquakes happen most often at the edges of these tectonic plates, which are called plate boundaries. Here, the plates interact with each other in different ways. Some plates are pulling apart, some are colliding, and others are sliding past each other. This constant movement and interaction is the primary driver of earthquakes. As the tectonic plates move, they don't always glide smoothly past one another. The edges of the plates are rough and irregular. Sometimes the plates get stuck. Even though the rest of the plate is still trying to move, the locked section resists. This causes stress and strain to build up in the rocks along the plate boundary. Think of bending a stick. As you bend it, stress builds up inside the wood. The more you bend it, the more stress accumulates. The stress along the stuck plate boundary continues to build over time. It's like stretching a rubber band tighter and tighter. Eventually, the stress becomes too great for the rocks to withstand. The rocks break or suddenly slip past each other along a fault line. A fault is essentially a crack in the Earth's crust where movement has occurred. When this sudden breaking or slipping happens, all the stored-up energy is released in a rush. This energy travels outward in the form of seismic waves, causing the ground to shake, an earthquake. The energy released during an earthquake travels through the Earth as different types of seismic waves. Some waves travel through the Earth's interior, while others travel along the surface. It's these surface waves that cause most of the shaking and damage we experience during an earthquake. The intensity of the shaking depends on the amount of energy released, the distance from the earthquake's origin, and the local geology. Scientists use instruments called seismographs to detect and record seismic waves. These recordings help them determine the location and magnitude of an earthquake. Magnitude is a measure of the energy released at the earthquake's source. Scales like the Richter scale or the moment magnitude scale are used to express this energy on a numerical scale. A higher number indicates a more powerful earthquake. History is filled with examples of powerful earthquakes caused by tectonic plate movement. The 1906 San Francisco earthquake, for instance, was caused by movement along the infamous San Andreas Fault, a transform boundary where the Pacific Plate slides past the North American Plate. The 1960 Valdivia earthquake in Chile, the most powerful ever recorded, occurred at a convergent boundary where the Nazca Plate is subducting beneath the South American Plate. More recently, the 2011 Tohoku earthquake off the coast of Japan was also a result of subduction, where the Pacific Plate is diving beneath the Okhotsk Plate. These events highlight the immense forces at play within our planet. While tectonic plate movement is the main cause of most large earthquakes, other factors can also trigger smaller seismic events. Volcanic activity can cause earthquakes as magma moves beneath the surface. Human activities, such as the injection of fluids deep underground, like in fracking, or the filling of large reservoirs, can also sometimes induce seismic activity. Understanding how earthquakes happen helps engineers design buildings and structures that can withstand shaking. While we can't stop earthquakes, we can prepare for them. Engineers use principles like flexibility, strength, and stable foundations to make buildings more resistant to seismic waves. They study how different materials and designs behave during shaking. Let's try a simple activity to see some of these principles in action. You'll need some building blocks, like Legos or wooden blocks, and a flat surface that you can shake gently, like a piece of cardboard or a tray. First, build a simple, rigid tower with your blocks. Make it tall and stiff. Place it on your shaking surface. Now gently shake the surface back and forth. Observe how your rigid tower reacts. Does it sway? Does it fall easily? Next, try building a different structure. Maybe make the base wider, or try connecting the blocks in a way that allows for a little flexibility, perhaps by using fewer interlocking pieces or creating joints. Place your new structure on the shaking surface and shake it again with similar force. Does it perform better than the first tower? Does it sway differently or stay standing longer? This simple experiment shows that the way a structure is built significantly affects how it responds to shaking. Engineers use much more complex versions of these ideas to design real-world buildings that can survive earthquakes. Earthquakes are a powerful reminder that our planet is constantly changing. They are primarily caused by the slow, relentless movement of giant tectonic plates beneath our feet. The stress that builds up at the boundaries of these plates is eventually released as seismic energy, causing the ground to shake. By studying earthquakes, we learn more about the Earth's interior and how to build safer communities in earthquake-prone areas.